নট এন আই বাই টু রয়েছে। হ্যাঁ, এবার সেখান থেকে খুব অল্প ডিস্টেন্সের মধ্যে বেড়ে নিউ নট এন আই হয়ে, হ্যাঁ খুব অল্প ডিস্টেন্সের মধ্যে বেড়ে নিউ নট এন আই হয়ে, এবং নিউ নট এন আই নাম্বারটা থ্রু আউট কনস্ট্যান্টই আছে। এই যে এই পার্টটা আর ওই পার্টটা, এটা হচ্ছে এন্ড এফেক্টটা। মানে আমি যদি সলিনয়েডটাকে এখানে ফেলি এরকম করে, তাহলে বলবো এইটা হচ্ছে আমার সেই সলিনয়েডটা, এরকম করে জড়ানো আছে, ঠিক আছে, এরকম করে আছে। যার সেন্টারটাকে লোকেট করেছি, এন্ড পয়েন্টটাকে লোকেট করেছি, এরকম করে গেছে, ঠিক আছে। এই যে ডিস্টেন্সটা হলো যার মধ্যে এটা চেঞ্জ হচ্ছে, রিয়েল সলিনয়েড, ঠিক আছে। এইখান থেকে আমি কি বলেছিলাম, আমি বলেছিলাম যে এই যে লেন্থটা হবে, এই লেন্থটা থাকবে, জেনারেলি থাকে তো সেন্টিমিটার রেঞ্জে থাকবে লেন্থটা, ঠিক আছে। আর এই যে রেডিয়াসটা রয়েছে, দ্যাট রেডিয়াস শুড বি ইন দা রেঞ্জ অফ মিলিমিটার। এবার বলা হয়েছিল যে আর্টটা ছোট হতে হবে কম্পেয়ার টু এল ডাইমেনশন। তার মানে যদি অল্প একটু ভেতরে ঢুকি, তাহলে গিয়ে যদি অল্প একটু ভেতরে ঢুকি, ধর আমি ধর বললাম এই হচ্ছে আমার সলিনয়েডটা, এরকম করে ছবিটা আঁকলাম, ঠিক আছে। এইটা হচ্ছে সেই পি পয়েন্ট, এইটা হচ্ছে সেই পি পয়েন্টে যেটা কিন্তু বাচ্চা রয়েছে, ধর বললাম যে এইটা বললাম 1 মিলিমিটার রেডিয়াসটা, আর এইটা ধর বলেছি আমি 100 মিলিমিটার। বোঝা গেছে কি বলতে চাইছি? 100 মিলিমিটার, তাহলে 1 সেন্টিমিটার হলো তো নাকি? না, 10 সেন্টিমিটার হয়েছে, এটা আবার 10 সেন্টিমিটার। এটা আইডিয়াল সলিনয়েডের গল্প হলো না। তুই ভাব যে তুই এন্ড পয়েন্টটা থেকে তুই স্লাইটলি একটু ভেতরে ঢুকবি, ধর বললাম যে এইখান থেকে তুই ঢুকেছিস কত দূর, ধর বললাম তুই 10 মিলিমিটার মধ্যে ঢুকে গেছিস, 10 মিলিমিটার মধ্যে ঢুকে গেছিস। যে পয়েন্টটাতে আছি সেই পয়েন্টে যদি দুটো পয়েন্টকে কানেক্ট করি, তাহলে এই অ্যাঙ্গেলটা বলবো θ2 অ্যাঙ্গেলটা, আর ওইটা হবে θ1 অ্যাঙ্গেল হবে তো। বোঝা গেছে? θ2টা যদি দেখতাম, বুঝতে পারছিস কথাটা? ট্যান θ2 ভ্যালুটা কত লিখবো? ট্যান θ2 ভ্যালুটা দেখ আসছে তোর এইটা বাই ওইটা, এইটা কত 1/90। বুঝা গেল? তাহলে অলমোস্ট এটা জিরোর দিকে এলো তো। θ2টা যদি টেন্ড করে জিরোর দিকে, তাহলে তার θ1 180 দিকে, মানে θ1 ধর টেন্ড করে গেছে 180 দিকে, এন্ডের দিকে, দেখতে পাচ্ছি। বোঝা গেছে? তখন অল্প একটু ঢুকলেই কিন্তু θ1 আর 90 থাকবে না, একদম এন্ড পয়েন্টে যখন আছি, এই ধর সলিনয়েডটা, এইটা হচ্ছে সেই পি পয়েন্টটা, আর এন্ডে আছে এইখানে। এই পয়েন্টে যখন এন্ড পয়েন্ট আছে, তখন দেখছি θ1 আমার হয়ে গেছে তোমার 90 ডিগ্রি হয়ে গেছে, আর θ2 0 ডিগ্রির কাছে হয়ে গেছে। ভালো কথা। কিন্তু যেই একটু ভেতরে ঢুকলাম, একটু 10 না করে তুই 2-3 কর, তাতেও চলে আসবে। তুই 2 মিলিমিটার ঢুকি, তাহলে এটা কত এসে গেল? 98 এসে 1/98, 10⁻0 আসছে তো। বুঝা গেছে? 10 মিনিটের না ঢুকে 2 মিনিটে ঢুক, তাহলেই দেখ θ2 জিরো ডিগ্রি চলে আসছে। θ0 মানে θ1 90 দিকে, মানে 180 দিকে চলে আসছে। কারণ θ1 যদি করতাম, ট্যান θ1 কত লিখতাম? ট্যান θ1 লিখতাম দেখ 1/10 বা 1/2 বা 1/4, যেটুকু ঢুকেছিস। এই নাম্বারটা ক্লোজ টু 1 এর কাছাকাছি চলে আসবে। এই আইডিয়াল আর রিয়েল সলিনয়েডের ডিফারেন্সটা ভালো করে বুঝতে হবে। তাহলে এতক্ষণ অব্দি যা আমরা করেছি সেটা হচ্ছে বার্নস ল এর অ্যাপ্লিকেশন, ঠিক আছে। এইখান থেকে এইটুকুর মধ্যে ভ্যারিয়েশন রয়েছে, এইখান থেকে এইটুকুর মধ্যে ভ্যারিয়েশন রয়েছে। ওই ছোট্ট জায়গাগুলো হচ্ছে মিউ নট এন আই বাই টু থেকে মিউ নট এন আই নাম্বার তৈরি করছে। হুম, ওটা হবে থ্রু আউট কনস্ট্যান্ট থাকবে। হ্যাঁ, থ্রু আউট কনস্ট্যান্ট থাকবে না, এন্ড একটু চেঞ্জ হবে। কিন্তু এই এন্ড এফেক্টটা মোস্ট অফ দ্য সিচুয়েশন আমরা ধরবো না আগে। হ্যাঁ, মোস্ট অফ আমরা ধরবো কি ম্যাগনেটিক ফিল্ড যখন সলিনয়েডের জন্য অ্যাপ্লাই করবো, পরে বারবার অনেকবার লিখতে হবে, সলিনয়েডের জন্য ম্যাগনেটিক ফিল্ড এক্সপ্রেশন লিখতে হবে। আমরা এই কনস্ট্যান্ট নাম্বারটা মিউ নট ইন্টু এন আই এটাই ধরবো। বুঝা গেছে? এইটাকে ধরবো আমরা, ওই এন্ড এফেক্টটাকে ধরবো না। ওকে, বলছে ফাইন্ড আউট দ্য ম্যাগনেটিক ফিল্ড ইন্টেন্সিটি অ্যাট দ্য অ্যাক্সিয়াল পয়েন্ট পি অফ দ্য সলিনয়েড অ্যাজ শোন ইন দ্য ফিগার। তাহলে একটা পয়েন্ট, জেনারেল পয়েন্টে বের করতে হবে। তাহলে জেনারেল পয়েন্টের জন্য ফর্মুলাটা কি ছিল? আমরা তো সলিনয়েডের জন্য এক্সট্রিম পয়েন্ট আর মিড পয়েন্টটা বের করেছিলাম, কারণ θ1 θ2কে আমরা সিম্পলিফাই করতে পেরেছিলাম। কিন্তু অ্যাজ এ হোল ফর্মুলাটা কি ছিল? ফর্মুলাটা ছিল মিউ নট এন আই বাই টু ইন্টু কস θ2 মাইনাস কস θ। মনে পড়ছে? θ2 কোন অ্যাঙ্গেলটা? ছোট অ্যাঙ্গেলটা। θ1 অ্যাঙ্গেলটা বড় অ্যাঙ্গেলটা ছিল। এখানে θ2 কত নেবো? পি পয়েন্ট থেকে একটা এন্ডকে দেখতে পেতে হবে, পি পয়েন্ট থেকে আরেকটা এন্ডকে দেখতে হবে। একটা এন্ডকে যখন দেখলাম 60 অ্যাঙ্গেল দেখতে পাচ্ছি, আরেকটা এন্ডকে যখন দেখবো তখন কত অ্যাঙ্গেলে দেখবো? 120 ডিগ্রি অ্যাঙ্গেলে দেখবো। θ1, ঠিক আছে, θ1 হচ্ছে 150 হলো। θ1 150, কস θ মানে ভ্যালু কত হবে? কস 150 ভ্যালু কত? মাইনাস কস 30। না, মাইনাস কস 30 মানে এটাকে √3/2 হয়ে যাবে। এটা হচ্ছে হাফ মাইনাস অফ মাইনাস √3/2, তাই তো? এরকম হচ্ছে গল্পটা। তাহলে 1 + √3/2 নাম্বারটা হবে। এইটা হবে উত্তর। বাই টুটা আছে একটা, আবার দুটো টু আসছে, মানে 4 হয়ে যাবে, 4 হবে না? এই যে একটা 2 রয়েছে আর এইখানে একটা 2 বেরোচ্ছে, দেখ এই 2 2 মিলে 4 হয়ে যাচ্ছে না? বুঝতে পারলি? তা করতে হবে, ঠিক আছে তো? থিটা ওয়ান থিটা টু গুলো কোনটা এক্সট্রিম পয়েন্টটাকে দেখছিস যখন, তখন পি থেকে, এটা কি আইডিয়াল সলিনয়েড? এটা কি আইডিয়াল? না, এটা আইডিয়াল নয়। আইডিয়াল কখন হবে? তুমি কি বলছি বারবার করে? এই জায়গাটা কনফিউজ হবে, বুঝতেই পারছি আমি। আইডিয়াল সলিনয়েড যখন বলা হচ্ছে, মানে তুমি দেখতেই পেতে হবে আইডিয়াল কখন হবে, যখন থিটা ওয়ান অ্যাঙ্গেলটা ক্লোজ টু 180 ডিগ্রি এরিয়া আর থিটা টু অ্যাঙ্গেলটা ক্লোজ টু 0 ডিগ্রি এরিয়া, তখন সেটা আইডিয়াল চলে। কিন্তু তা হচ্ছে আলাদা আলাদা অ্যাঙ্গেল আসছে না, এটা নন আইডিয়াল, এটা রিয়েল সলিনয়েড, হয়েছে? আর পারবো না, ঠিক আছে? এটা পারবি তো নাকি? বল দেখি, অ্যাট এনি ইন্টারনাল পয়েন্ট ভেতরে of a solenoid the value of magnetic field produced depends on what? ভেতরে কি হয়? ভেতরে ফর্মুলা হচ্ছে মিউ নট এন আই, এরকম করে ভাব, অস্থির বস্ত্র উড়িয়ে দে। তাহলে অনলি অন দ্য কারেন্ট ফ্লোয়িং অন দ্য সলিনয়েড, হ্যাঁ ঠিক। অনলি অন দ্য লেন্থ, লেন্থের উপর ডিপেন্ড করবে কি? লেন্থের উপর ডিপেন্ড করবে, হ্যাঁ ডিপেন্ড করবে, কারণ ছোট এনটার মধ্যে দেখ, ক্যাপিটাল ছোট এনটাকে লেখা ছিল ক্যাপিটাল এন বাই এল, মনে পড়ছে? ছোট এনটা মানে ক্যাপিটাল এন বাই এল, তাহলে লেন্থের উপর ডিপেন্ড করবে। অন দ্য নাম্বার অফ টার্মস মানে ক্যাপিটাল এন আছে, তাহলে অন অল দ্য অ্যাবাভ, ঠিক আছে? অল দ্য অ্যাবাভ প্যারামিটার্স সবকটার উপর ডিপেন্ড করবে। খুব ভালো করে কেয়ারফুলি পড়তে হবে কিন্তু চ্যাপ্টারটা, কারণ এই চ্যাপ্টারে যদি নড়বড় হয় তাহলে কিন্তু পরের চ্যাপ্টার একদম পুরো গোল হয়ে যাবে, বলে রাখছি কিন্তু বারবার। ম্যাগনেটিজম হচ্ছে সব থেকে ভালো চ্যাপ্টার, ক্লাস 12 11 মিলিয়ে সব থেকে ভালো চ্যাপ্টার। এই চ্যাপ্টারটা যত কনফিডেন্স পাবি তত ইএমআই তে ভালো মাথা খাটাতে পারবি, আর ইএমআই ফিমআই যদি তাগড়া তৈরি হয়ে যায়, যে কোনো কম্পিটিটিভ এক্সাম ভালো করে পাবে। কারণ কি হচ্ছে, এই দুটো চ্যাপ্টার থেকে কিন্তু ভালো কোশ্চেন থাকে এবং করা খুব সোজা, যদি কনসেপ্ট ক্লিয়ার থাকে। যদি কনসেপ্ট ক্লিয়ার না থাকে তাহলে একদম দাঁড়িয়ে দাঁড়িয়ে কি করবি, কান্নাকাটি করে চলে আসবে। যেমন করে বায়ার সাওয়ার ল দিয়ে তুই ফোর্স বের করে ফেলছিস। কালকে শুনে রাত্রেবেলাতে বায়ার ফোন করেছি, বায়ার ফোন করে বলছি কি হয়েছে দাদা, তুমি পড়াচ্ছ এরকম করে আর ছেলেগুলো এইসব বলছে, আমি কি আর করবো, তোমার ল দিয়ে ওরা ফোর্স বের করে ফেলছে, হয়েছে? হ্যাঁ, ভুল হয়ে গেল, কান ধরেছিস? এগোই আজকের টপিকে। আজকের টপিকটা খুব সোজাটাই, হালকা টপিক, গস লর মতো। গস ল সোজা ছিল তো, এক্স্যাক্টলি সেম ধরনের একটা ল শিখবো টুডে। আমরা করছি কি, দেয়ার ইজ এ অ্যানাদার কাইন্ড অফ ল হুইচ ইজ কল্ড দ্য অ্যাম্পিয়ার্স ল, হুইচ ইজ সিমিলার টু দ্য গস ল দ্যাট উই হ্যাভ লার্ন ফর দ্য ইলেকট্রোস্ট্যাটিক্স। ওকে, সো ইলেকট্রোস্ট্যাটিক যখন করেছিলাম, সো ইন দ্যাট সিচুয়েশন দ্য গস ল যেটা আমরা শিখেছি, গস ল ইজ হাউ মাচ, হোয়াট ইজ, সো সারফেস ইন্টিগ্রাল অফ ই ডট ডিএ শুড বি ইকুয়ালস টু কিউবিন বাই এপসিলন নট লেখা হতো। What is qubin? Qubin is the net inside charge. Qubin is the net inside charge. And for the Ampere's law, যখন Ampere's law আমরা ইউজ করবো, তখন সেম ফর্মুলাটাকে যদি চেঞ্জ করে দেবো, এরকম করে লিখবো ইন্টিগ্রেশন অফ বি ডট ডিএল, and this is called the line integral. It is called line integral. Why? Because I am doing an integral along a particular line. That line is basically a line. এই লাইনটাকে বলা হয় Ampere's loop. এইখানে এটি কি বলা হতো, A is the surface, so it is called the Gaussian surface. Okay, এখানে DL is the length, it is called the Ampere loop. Okay, এটাকে বলা হচ্ছে Ampere loop. That should be equal to, instead of qubin আমরা লিখব কি I, so mu naught into I in, mu naught into I inside. So that is the expression for the amperes. So more or less same, একই রকম চেহারা রয়েছে, but there is certain restriction about this amperes law, because এই অ্যাম্পিয়ার্স লটাকে একটু মডিফাইড ফর্মে পড়বো আমরা কিছুদিন পরে গিয়ে, যখন আমরা এই চ্যাপ্টারের মধ্যে ঢুকবো। আমরা যখন পড়বো তোমার ইএমআই চ্যাপ্টারে, আগে একটা টপিক আছে যেখানে আমরা শিখবো যে এইখানে এই নাম্বারটা কিন্তু এক্স্যাক্টলি এই নাম্বারই হবে না এইখানে, বিকজ হেয়ার আই মিনস হোয়াট এভার দ্য কারেন্ট দ্যাট ইজ ফ্লোয়িং থ্রু দ্য সার্কিট ইজ কল্ড দ্য কন্ডাকশন। হ্যাঁ, is called the conduction current. Why? Because this current is taking place due to the conduction of electron. Electrons are moving, because of that the current that is flowing inside the circuit, সেই কারেন্টের নাম হলো conduction current. For conduction current, this Ampere's law is perfect. But there is some situation where আমরা দেখবো যে because of some kind of magnetic field develop, some another current is being produced. That is called the displacement current. Okay, so concept of displacement current will come later part of the topic. So when the concept of displacement ID will come, then the Ampere's law has to be modified. Ampere's law cannot be written in English. ডিসপ্লেসমেন্ট কারণ কি ডিসপ্লেসমেন্টের জন্য হচ্ছে, যেটা এখন বুঝবো না। কেন আমরা এটুকু এখন বুঝেছি যে আমি যদি ভাবি যে একটা ম্যাগনেটিক ফিল্ড তৈরি করতে হবে, হু ইজ রেসপন্সিবল টু প্রডিউস দ্য ম্যাগনেটিক, এবার এর উত্তর দিত, হু ইজ রেসপন্সিবল টু প্রডিউস দ্য ম্যাগনেটিক, কার জন্য? তোর বাবা মাথা থেকে পাওয়া দিয়ে জ্বালিয়ে দিবি রে, ম্যাগনেটে দুটো পোল লাগবে। ওরে ভাই, এই চ্যাপ্টারের মধ্যে পার্মানেন্ট ম্যাগনেটটাকে একটু দূরে সরিয়ে রাখ। হ্যাঁ, ছোটবেলা থেকে চোখের সামনে বার ম্যাগনেট, হর্সু ম্যাগনেট দেখে দেখে মাথার চুল নড়ে গেছে। এখন এই বার ম্যাগনেট, হর্সু ম্যাগনেট থেকে বেরিয়ে এসে অন্য একটা ম্যাগনেটকে ভাবার চেষ্টা কর, দ্যাট ইজ দ্য ইলেকট্রোম্যাগনেট। Because every magnet that we are discussing over here is basically electromagnet. Why? Because magnetic field can only be produced when the current is being flowed. আমরা সবকটা তাই দেখলাম তো। So there is a wire, through this wire some current is being flowing I. So if I is there, it can produce the magnetic, that is equal to mu naught I by 2 pi r. এইসব করতে পারে ইনফাইনাইট ওয়্যারের জন্য। লুপের জন্য দেখেছিলাম mu naught I by 2 r, সলিনয়েডের জন্য দেখলাম mu naught into ni. So every time the magnetic field is being produced by whom? By current. If current is there, then the magnetic field is being produced. বোঝা গেছে এই জায়গাটা? Without current I cannot produce the magnetic. So what we understand that I is responsible to produce the B. এটা কি বোঝা গেল? So I will produce the B number. Now indirectly opposite thing is also possible. E can produce the I. So that is the basic of EMI chapter. So in EMI chapter I will learn, or rather we will learn, that how to produce the current from B. তাহলে B যদি থাকে তাহলে কারেন্ট তৈরি হতে পারে। So there are some situation where the B is being produced. Yeah, there are some situation where the magnetic field is being produced due to the change in electric field. ঠিক আছে, এবার EMI is one particular chapter where all the concept comes. যা যা শিখেছি সবকিছু ওখানে আসে, তখন বুঝবো যে কেমন করে ডিসপ্লেসমেন্ট আসছে। বোঝা গেছে? এখন বললে কিচ্ছু বুঝি না, কারণ EMI না জানলে আইডি বোঝা যায়। সো এখন যা যা কারেন্টের কথা বলা হবে অল আর বেসিক্যালি দ্য কন্ডাকশন কারেন্ট। ওকে, এখন মনে কর ডিসপ্লেসমেন্ট কারেন্ট বলে কিছু জিনিস শেখানোই হয়নি। সো অনলি আই ইজ নোন, এন্ড ফরগেট অ্যাবাউট দ্য নেম কন্ডাকশন কারেন্ট, অনলি আই, simply I. I is flowing through a wire. Current carrying conductor is there, through that the conduction electron takes place. Because of that, the current that is being flowing, that is called the conduction current, and simply I am writing I. So for I, some kind of B is happening. So এইটা হচ্ছে এখানে Ampere's law. Now I want to apply. Now remember, কোথায় কোথায় আমরা Gauss law apply করেছিলাম মনে পড়ছে? Gauss law কখন apply করতে হয়? Gauss law has to be applied in those situations where the problem cannot be solved, or if I use the Coulomb's law, then the problem will be difficult. ঠিক আছে, এমন কিছু সিচুয়েশন আছে যেখানে আমরা Coulomb's law যদি অ্যাপ্লাই করি, তো that can give the result, but the calculation procedure or the integration procedure may be so difficult that it may not be possible to get the answer in a quick error. So for those situations, I can apply the Gauss law. So there is no such rule that Gauss law cannot be applied over here, or Gauss law has to be applied over there. But the rule is that in order to make the problem simplified, so I have to use the Gauss law. Same is the logic for the Ampere's. Okay, so both the laws are more or less same, statement wise more or less same, mathematical expression wise more or less same. Only thing is that you have to apply this law. So similar to the Gauss law, now we learn about the Ampere's law. So recall the Gauss law. So in order to find the electric field, I used to calculate the Gauss law. So for Gauss law, I have to use a surface. Surface means a closed surface. It cannot be open surface. So for a current carrying wire, for a charge wire, let us say infinite amount of charge, if I say there is a cylindrical Gaussian surface, this is the Gaussian surface. So about which I have to take the integration. So if I integrate it, surface integral of E dot dA should be equals to Q in by epsilon. This is the formula. I have to apply this formula. So for electric field is symmetrical in this situation. In this situation, for the charge wire, electric field is always radially outward. electric field is radially outward. So if I take one area over here, so for this dA, electric field dA vector is in this direction. So both dA and E vector are parallel to each other. So that means theta equals to 0 degree. Okay, because there is a dot product. But for the surface, upper or lower surface, area vector is upward or downward. If I say this is the dA vector upward, for this situation, E vector is parallel to this. That means this angle is 90 degree. So upper surface, so this is the surface integration. So there are two surfaces. One is the curved one plus a flat surface. So rather there are two flat surfaces. So for flat surface, E vector is perpendicular to A vector. For curved surface, E vector is parallel to A vector. That means this will give zero result. So only I have to left with E parallel to A. So if I say radial direction E is uniform, so E dot dA means E will come out. Why? Because E is constant. So integration of dA, that should be equal to Q in by epsilon. What is Q in? Q is nothing but the enclosed charge. So if I say the cylinder will enclose this much portion of the wire, so what is the charge inside this wire? Charge is lambda times L. If I say L is the length of the cylinder, so Q in is lambda into L. Why? Lambda is the unit charge per unit length. Lambda is the charge per unit length. So it can be written as lambda into L by epsilon naught. Okay, lambda into L by epsilon. Now what is dA? dA is the surface area. Why? Because I am only taking the curved surface, not the flat one. So only the curved area. So E into 2 pi r into L, that is the curved surface area. That's equals to lambda L by epsilon naught. So ultimately L cancels out. We are left with E equals to lambda by 2 pi epsilon naught into r. Now 1 by 2 pi epsilon is 2k. So 2k lambda by r, that is the final expression of electric field into the charge wire of infinite. 2k lambda by r. So this is the application of the Gauss law that we have already learned in the electrostatic physics. Now we move on to the calculation of the Ampere. So for finding electric field in symmetrical charge distribution, we will use the Gauss law. So to find the magnetic field in a symmetrical current distribution, so statement is also analogous. Okay. So only thing you have to remember that Ampere's law are applied for calculation of magnetic field, and Gauss law is applied to calculate the electric field. So whenever I apply the Ampere's law, then in order to make the problem simpler, so I have to apply this for symmetrical current distribution. Ampere's law is to Biot-Savart law, but Gauss law is to Coulomb's law. In electrostatics, I have proved that from Coulomb's law I can derive Gauss law, or from Gauss law I can derive Coulomb's law. Same is the logic for Biot-Savart. From Biot-Savart I can derive Ampere, or for Ampere I can derive Biot-Savart. So both are complementing each other. Either I can use Biot-Savart law or Ampere's law, or I can use Gauss law or Coulomb's law. Okay. So now forget about the Gauss law and Coulomb's law, because now we are not bothered about to calculate the electric field. I am only bothering about to calculate the magnetic field. So I am concentrating on the Ampere's law, because Biot-Savart law is already learned. I want to calculate the Ampere's law or apply the Ampere's law. Okay. So now for that I have to select an Ampere in circuit, similar to the Gauss surface. Here I have to select an Ampere in circuit. So that is a loop. So loop on which Ampere's law is to be applied is called the Ampere circuit. Okay. So that loop must be a closed one. This must be a closed one. Similarly, the surface that we have taken for the Gaussian equation is also a closed one. So circuit, closed path, closed curve, these are called loops. So any term you can use. A loop means a circuit, a loop means a closed path, a loop means a closed curve, or loop. Now assign a direction using arrow. So once you draw the loop, now take the direction, any arbitrary direction, any direction you take it. So mark this direction. Okay. Now once I mark this direction, now if I curl my finger along this direction, so that means I am curling my finger in this direction. So my thumb is pointed inward. My thumb is pointed inward. Okay. So depending on the direction of thumb, why? First step is to assign the direction of the arrow. Once I assign the direction of the arrow, now I can rotate my finger. And if I rotate my finger, curl my finger, then my thumb is pointed inward. So inward direction has to be taken as the positive. Okay, inward is the direction of positive one, and that direction is basically the direction A. Okay. So every time first you assign the direction of arrow or direction of current flow. So that direction is basically the direction inside which you am inside the loop I am moving. Okay, and if I say that is clockwise, then cross is the positive direction. Inside in that direction, I am taking the area. Use the right hand thumb rule for assigning one side of curve as positive. So I am taking for this particular direction, cross is the positive one, finger along the direction of the arrow, and thumb gives the positive direction. Okay, this is the first step that you have to do in order to mention what is the positive direction and what is the negative. Why? Because if you remember about the Gauss law, so if I say this is the Gaussian surface, some charges are positive and some charges are negative. Okay, some charges are negative. So I have to take care about the Q inside. So since charge is scalar quantity, I will apply it as a scalar addition. So it should be in this situation 2Q is positive, 1Q is negative. So ultimately Q is basically Q. Okay, but here, see, current is also a scalar quantity, but the direction of current is important. Yeah, direction of current is important. Why? Because it is scalar, but scalar is not proper true. It is basically called as a tensor quantity because now we understand the direction has to be taken. So anywhere which is carrying the current in the cross direction is to be taken as positive. Anywhere which is carrying the current in the dot direction should be taken as negative. That will give the value of total I inside. Okay. So for this equation, if I rotate in this direction, so then dot becomes positive direction. Okay. In this equation, cross become positive. Cross become positive. So cross become positive means every time I will take the area as positive direction. Area has to be taken in the cross direction. Here I am taking area as the negative direction, the dot direction. Okay. So once I select the direction of arrow, now I can directly give the corresponding direction of the area. Okay. Now let us say I am moving from this point to this point. Let us say I am moving from this point to this point, that is dl distance along the loop, and I am moving in this direction. Okay. So let us say the B is making an angle theta with this direction. B is the magnetic field at this point. So B is making an angle theta with the dl vector. So if I do the line integral, so B dot dl will give the line integral. Okay. If I integrate the B over the length, so that is giving the value of B dot dl. That means in order to evaluate this integration, I must know the value of theta. Okay. Why? Because if I expand this, that should be equal to line integral of B dl cos theta. B cos theta into dl. That means the theta number is changing. So for this movement, let us say this is the dl vector. Let us say at this point the B is in this direction. Okay. That means the theta may be changed. So let us say this theta prime. Here let us say I am moving from this point to this point. Let us say the B is in this direction. So again the theta angle is changed, theta double prime. So every time depending on the location of the point along the line, if I move, the theta angle may be changed. But in order to simplify this problem, I have to assign a theta that should be either 0 degree or 90 degree. If I say I choose a particular surface or line, I am moving along a particular line. So for that line, let us say B is making an angle theta with dl vector, and that theta is 0 degree. Then it will make the life easier because the cos theta means 1. Okay. If theta equals to 90 degree, then the dot product entire becomes 0. B dot dl number will be 0. Okay. That means I don't have to do any kind of integration. So either I have to choose a particular loop where the theta becomes 0 degree, or I have to choose a loop where theta becomes 90. Because loop is in Ampere. I have to decide about the loop. I can choose any type of loop, but whatever the loop is easier for the calculation, that you have to decide. So one restriction is that you have to choose a value of L. You have to choose a direction along which you have to move. The theta angle, this theta angle may be 0 degree, maybe 90. If you take any value of theta, then the problem will be much more complex, and it may be such that you cannot perform the integration itself. Because if theta is variable, if you don't know how the theta is varying, that means you cannot formulate the integration. So until and unless I can form this left hand side integration, I cannot evaluate it. Okay, so in order to evaluate the integration, you have to go for a less complicated value of theta, and one of the easiest value of theta is either 0 degree or 90 degree. Okay, so this is the statement. Statement says that B dot dl equals to mu naught into I net. What is the I net? Similar to the Gauss law. So I net is the net current inside the area bounded by the car. So inside this, let us say there is another wire of I1 current, this is the I2 current, this is the I3 current, and this is, let us say, I4 current like this. So as I am moving along this purple color direction, so I know that cross is positive. So I net should be how much? I net should be equals to I2 plus I3 minus I1 plus I. This is our I net value for this situation. Okay. So once I assign the direction of the arrow, then only I can ensure which one is positive side and which one is the negative side. Depending on that, you calculate the value of I net. If only one single wire is there, then only one I. If multiple wire comes in inside that inside that Ampere loop, then according to that, you have to calculate the net I. Okay. So once we calculate the net I, net situation is to calculate the integration. So let us say for this situation, so there will be some wire which are outside the loop. So don't take this effect. So inside the I net component, only consider the I that is inside the loop. So according to the direction, so cross is positive, cross is positive. Okay, that means what is the value of I net? I net should be equal to I3 minus I1 minus I2. I3 minus I1 minus I2, because I1 I2 is the dot direction. So whenever I take the I net value, you don't have to bother about the wire that are placed outside the loop. Okay, because I am deciding about the loop. So once I decide the loop, then whatever the current carrying conductors are there that are placed outside the loop, for that loop or for that wire, you don't have to take about the I. But once I calculate the B, so recall the Gauss law again. So what is B? B is the net electric, net magnetic field, net magnetic field. And once I am saying net magnetic field has to be produced by all the current carrying. Okay, so inside this B, the effect of I1, I2, I3, I4, I5, all are there. Similar to the situation where I write E dot BA equals to Q in by Q naught. What is E? E is the net electric field produced by all the charges, whether it is inside or outside. B is the net magnetic field produced by all the current carrying conductor, whether it is inside or outside. Okay, so these statements are to be applied very carefully. Okay, so once I am calculating the B number, that means I am calculating B value for all the wire, whether it is inside or outside this material. Okay, so I net is the net current, B is the resultant magnetic field due to all current distribution. Okay, all current distribution. So once I formulate the problem, now I can go for the calculation. So let us say there is one loop. Okay, so one loop, for that different currents are being flown. So according to the direction of the purple color arrow that is being given, so I know that in this equation dot is to be taken as the positive one. Dot is positive one. So dot positive one means I1, 2, 3 are positive, 4 and 6 are negative. So what is I net? I net should be equal to I1 plus I2 plus I3 minus I4 minus I6. Okay, now put the 1 is 1, 2 is 2, 3 is 3. 1, 2, 3, 3, 2, 5, 6 is 6 minus I4. I4 is 1 and I6 is 5. I5 is 6, I6 is 4. I6 is 4. So ultimately 1 ampere. Okay, that is the mu net, I net number. Okay, so integration of B dot BL should be equal to how much? Mu naught into I net. What is I net? That is equal to simply 1, so actually mu naught. Okay, so this is the value of the line. So you are asked to calculate the value of the line integral B dot dl around the closed path in the anticlockwise sense. So if that is given, then you can decide which one is positive and which one is negative. If it is not mentioned, so accordingly you have to mention it and give the answer. Okay, so if it is not mentioned, then in the answer box, ABCD options, that should be mentioned. Okay. So now calculate the magnetic. So I want to go for the application. So already I know the B due to infinitely long thin wire is equals to how much? Infinite wire means B is equals to mu naught I by 2R. 2 pi R. That is the answer. Okay. I want to evaluate that whether I am getting the same answer or not. Let us say there is a wire. Through this wire, the current is being flowing. And if I say the current is being flowing in the dot direction, that means dot is our positive direction. Why? Because I take the ampere loop in the dot direction. Okay. So now B dot dl. So whatever the magnetic field produced around this, so this is the ampere loop. This is the loop. and this is the wire. Through this where the current is being flowing. Okay, this is the wire, and current is being flowing in the dot direction. So B dot dl, that is basically B, and what is the dl vector? So for this situation, what I am saying that the dl is in this direction. dl is in this direction. Now, whatever the magnetic field produced by this current carrying wire should be along this wire, along this loop. Why? Because I know that for a symmetrical geometry, so B should be in this direction, circular loop. Okay, so B is in this direction, dl is also same direction. So both B and dl are parallel to each other. Both B and dl are parallel to each other means theta is 0 degree. So B dot dl, simply B is constant. Why? Because each points are equal distance away from the wire. So by logic I know that at each and every point magnetic field will be same. At each and every point magnetic field will be same. So B is uniform. So take B outside, integration of dl should be equals to mu naught into I net, and only one single wire is there. So I net is I. So B, and dl means total loop length. Total loop length is 2 pi r, because 2 pi r is a perimeter. That's equal to mu naught into I. So B becomes mu naught I by 2 pi r. That is the same answer that we have already obtained by using the Ward-Sauber law. Okay, now I am verifying the result from the Ampere's. So Ampere's law will also give the same result. So now we can modify this. How? So tips for selecting the ideal surface, Ampere surface. So I have already mentioned that every point the magnetic field line should be uniform or G. So either you have to select a loop, about that loop, so either the B will be uniform, that is B is constant, like the previous problem, or B will be 0, and at each and every point the B may be parallel to the dl vector or anti-parallel to the real vector, and it may be perpendicular. So theta becomes 0 degree over here, theta becomes 90 degree over here. So this will make the life easier to us, because the dot product, the integration will be easier. You don't have to do the dot product. So cos theta part is simply eliminated. So only thing is that I have to do the B dot dl integration. Okay. So for that, this is the correct way to select the Ampere. Now I want to go deeper inside this wire pattern, cylindrical wire. So I already established the formula that B magnetic field into current carrying wire is equals to mu naught I by 2 pi r, that is the outside point. Okay. So now I want to calculate the hollow cylindrical wire. So this is the hollow wire, hollow cylindrical wire. Okay, inside which there is no material. This is hollow wire. Okay, I want to calculate. So this is not the wire. So wire is this one. The white color is the wire. So this is the hollow cylindrical wire. I want to calculate the B value at inside. So for inside point, I am taking, this is our loop. This is our loop. So whatever the B must be there for this inside loop. So this is the loop about which I am taking the Ampere law. So for that situation, current is only on this perimeter wire. So there is no material inside. So no material inside means at this point I net becomes 0. So I net 0 means whole integration B, if it is there, dl means 2 pi r, integration that should be equal to 0. So ultimately B inside is 0. If the wire is hollow, then B inside is G. If the wire is hollow, cylindrical wire, I am now going inside the wire, not the outside. Outside part formula remains same. Outside part. So for the point which is outside, again this is a hollow wire, and I am moving, this is the point which is outside wire, the Ampere loop. Okay. So Ampere loop is there. So for this loop, if I apply the B dot dl formula, again the theta becomes 0 degree. So what about the I net? I net is the total I that comes into the circuit. So mu naught into I. And what is dl? dl is 2 pi r. So B into 2 pi r. So I am getting the same result of the infinite where B equals to mu naught I by 2 pi. Okay. So that is for the hollow wire. Hollow wire outside, hollow wire inside. So if hollow wire is being plotted, so inside there is no magnetic field. Outside the magnetic field is mu naught I by 2 pi r. Okay. So inside there is no magnetic field. Outside the variation is hyperbolic because it is inverse proportional to r. So the plotting is also important. Plotting is also important. So at the center point, at the surface point, let us say this is the surface point capital R. So from starting from 0 to capital R, there is no variation of B. Straight line. At capital R, It increases and then it goes on decreasing. Okay. So this point is the point on the surface itself. So I cannot define the exact point. I cannot say on the surface of the wire equals to mu naught I by 2 pi capital R. That is not logical. But what I can predict that at this point, the B should be on the higher side. Yeah, B should be on the higher side. So here the variation is inverse proportion to 1 upon. Okay. So outside point mu naught I by 2 pi. Inside point it is equals B equals to 0. B equals to 0. Okay. And surface point, if I say surface point, that can be taken as mu naught I by 2 pi r, right? Because on this surface I am taking small r equals to capital R. Okay. But for a wire, I cannot define the surface. For a wire, if I say this is the wire through the current is being flowing, if I want to calculate what is the B at this point, O point, I cannot define because it is infinite. But for a hollow wire, I can define that surface point is existing, but that surface point number is mu naught I by 2 pi capital R. Why? Because it is on the surface. Now come the solid wire. Now solid wire means now the current is. Now B equals to 0 হচ্ছে এই পয়েন্ট। আচ্ছা ঠিক এই লাইনটা ভুল করা এইটা কাটাতে পারবে না, এই লাইনটা নিচে হবে। হ্যাঁ, এই লাইনটা নিচে হবে, এই লাইনটা নেই। ভ্যারিয়েশনটা হচ্ছে এরকম, ভ্যারিয়েশনটা হচ্ছে ইনসাইডে 0 হচ্ছে, তারপর ডিসকাউন্টিং রয়েছে, তারপর হচ্ছে ইনসাইডে 0। Now come to solid wire. So solid wire means the current is there. Okay. So for this equation, since the wire is solid, now in order to calculate the I net, so I must know the value of J, current density. Let us say the uniform current density wire is there, J. Okay. So again, if I go for the inside loop, this is the Ampere loop which is inside. First we calculate the inside point. So left hand side integration is remaining the same, that is B into 2 pi r. No change. Okay. 2 pi is the length. And what about the I net? I net should be J into pi small r square. Okay. Remember the value of J. J into area, that is equal to I number. J is called the current density. So I multiply that this area inside the loop part. So that part of the loop is basically the I net part. I don't have to take whatever happening outside the loop. So J into pi r square. So once I simplify this, I am getting mu naught J r by 2. So very, very important result for a solid wire which is having some kind of current inside. Now the variation of E is mu naught J r by 2. And mu naught J r by 2 variation is there, that means variation is linear. The variation is linear starting from 0 at the center. So at the center of the wire, at center, that means small r equals to 0. So small r equals to 0, it means that B is equals to G. But the variation is linear because direct proportion to R. Okay. And about the outside point, if I consider the outside loop, so this is the outside loop. So for outside loop, again, if I do the same calculation, so it should be equal to B into 2 pi r. And now the total current will come into the picture. So inside the I net, mu naught into I will be there. Okay. So ultimately what I am getting, B equals to mu naught I by 2 pi r. So what we learned from this two exercise is that whether the solid wire is there or the hollow wire is there, outside point value is remaining same. But for solid wire, there is an inside magnetic. And that inside magnetic field is straight line. So mu naught, either I can write in terms of I or in terms of J. So I am proposing the formula that is B equals to mu naught J r by 2. And what is J? J is basically equals to I divided by pi capital R square. Okay, once I put it over here, so mu naught J means I divided by pi capital R square into small r by 2. I am getting the same result. That is mu naught I into small r by 2 pi capital R square. So that result is not so much popular. This result is much popular. Okay. So you have to remember the B value as mu naught J r by 2 provided J number is constant. If the J is a variable, then you have to integrate it again. Okay. So for some time you consider that J number is constant, and for that the B is equals to mu naught J r by 2 inside. Outside is same formula, mu naught I by 2 pi. There is no change. Okay, outside part is not changing. So if I plot the variation, now the inside part is linear, then outside part is this one. So at this point, if I solve it as mu here, if I for this diagram, this number should be equal to mu naught j capital R by 2. And for this point, for this curve, it should be equal to mu naught I by 2 pi capital R. So these two numbers are equal. Why? Mu naught j capital R by 2 is equals to mu naught j means I divided by 2 pi R square into R. So if we simplify it, so it gives mu naught I by 2 pi R. That is the same number that I am getting. So there is no discontinuity at this particular point. Okay. So both the lines are matching exactly at this point. So whatever the magnetic field is increasing, that is within the solid part, within the material part. And once I move outside the material, that means once I am coming outside the material, then the magnetic field is decreasing. Inside magnetic field is increasing, outside it is decreasing, and there is no discontinuity. But for the hollow part, there is a discontinuity. Inside part is 0, outside part is value. So this is the variation. It is proportional to R, not A. It is proportional to R, 1 by R. So this is the variation of the solid wire and the hollow. Okay. কোনো ডাউট আছে কিনা বল, এরপর ভালো অঙ্ক করে দেখ। এই দুটো ফরম্যাটকে ভালো করে মাথায় রাখতে হবে। হ্যাঁ, এই দুটো ফরম্যাটকে ভালো করে মাথায় রাখতে হবে, তবে গিয়ে ভালো অঙ্ক করতে হবে। ভালো অঙ্ক দুটো চারটে দেখাচ্ছি, তাহলে মাথা ঠিক। আগে দুটো ফর্মুলা ভালো করে বুঝেছিস কি বুঝিসনি, কোথাও অ্যাম্পিয়ার ল লাগাতে কি অসুবিধা হচ্ছে কি হচ্ছে না বল। একটু জল খাই, বেঁকে হয়রান হয়। এই যে বায়ার সাভার ল, লাইন এলিমেন্টটা কোন দিকে নেবো না কি বললি, কেমন করে নেবো? সবসময় নেবো কারেন্ট, তোকে দেখতে হতে হবে কারেন্টটা কেমন করে দেওয়া হয়েছে। এই ধর বলা হচ্ছে কারেন্টটা উপরের দিকে ছবি দিচ্ছে, ঠিক আছে? ক্রস বা ডট কিছু একটা বলা থাকবে তোকে। হ্যাঁ, ক্রস বা ডট কিছু একটা বলা থাকবে। ধর বললাম এইটাকে টপ ভিউতে দেখছিস, তাহলে কেমন দেখবি? টপ ভিউতে একটা সার্কিট দেখবি এরকম করে। তারপর কি দেখবি? কারেন্টটা কেমন করে দেখবি? ডট দেখবো তো। তাহলে অ্যাম্পিয়ার লুপটাকে যখন নেবো ভেতরে, আমি নেবো এরকম করে ঘোরাবো, এই দিয়ে ঘোরাবো। বোঝা গেছে? ডট পেলাম তো, এইভাবে হবে। কারেন্টের ডিরেকশন দেখতে পেতে হবে, কারেন্টটা কোন দিকে, সেইভাবে লুপটাকে নেওয়ার চেষ্টা। কারণ এটা তুই উল্টো দিকে নিলে আনসার কিছু চেঞ্জ হবে না। উল্টো দিকে আনসার কখনো চেঞ্জ হবে না, কিন্তু আমি এই কনভেনশনটাকে আবার আরেকবার ইউজ করবো তখন ইএমআই চ্যাপ্টার, ঠিক আছে? তখন দেখবো এটা আরো খুব কাজে দিচ্ছে। সেই কারণে প্রথম থেকে এইভাবে শিখছি যে আমরা কারেন্টটা যেদিকে থাকবে সেদিকে আমি লুপটাকে ঘোরাবো, সেই দিক থেকে পজিটিভ বলে এগো। এবার অন্যদিকে যদি থাকে তাহলে সেটাকে নেগেটিভ করে দেবো। যদি দুটো থাকে, ধর উপরের দিকে আছে নিচের দিকে, তখন ডিসাইড করতে পারছি না কোনটা নেওয়া উচিত, যে কোনো একটা দিকে পজিটিভ বলে উল্টো দিকে অটোমেটিক নেগেটিভ করে আসবে। বুঝে গেছে? লুপের সিলেকশনটা এন্টারলি তোর হাতে, তুই কেমন করে নিবি তার উপর দিকে, ঠিক আছে? এটা একটু বলি অঙ্কটা, তারপর ভুলভাল গুলো সরে গেছে কেমন একটা মনে হচ্ছে, যাই let us say there is a solid wire. It is a solid wire representing a solid wire, through which some current is being flowing, whose J value is given as, let us say, J naught into small r. What is small r? Small r is the radial distance from point P. Okay. Total radius is given as 2r. So you are asked to calculate the magnetic field at point P. So not point P. So let us say this is the point O. Let us say this is the point O. No, O is the center point. And let us say I want to calculate the magnetic field at a point P, which is a distance of, let us say this distance is R, capital R. Okay, what is the magnetic? So at this point I cannot apply the formula mu naught JR by 2. Why? Because now the J is varying. Now the J is variable. So I have to start from the very base. I have to apply the Ampere's law and I have to get the rate. Okay. So in order to apply the Ampere's law, let us say inside the cross section, I am taking an Ampere loop like this. In which direction I should rotate? Clockwise or anti-clockwise? Clockwise. Because if I rotate clockwise, then it would cross. Okay, so I am rotating clockwise, starting from O. Let us say this is the R radius. the radius. Okay. So I want to calculate what is the magnetic field at smaller distance. Okay. Magnetic field at smaller distance. So formula should be equal to how much? Here if I apply the magnetic field, so it should be mu B into dot dl means 2 pi r. Left hand side integration. That should be equal to mu naught into I net. But I don't know what is I net. So I have to calculate this I net number. Okay. So in order to so ultimately what we write that B should be equals to mu naught into I net by 2 pi small r. That is the variation of B within the cell, inside part. Okay, here I am inside. Outside part there is no issue. For outside there is no issue. Only thing I want to calculate what is the inside part B. So B inside equals to mu naught into I net by 2 pi small r. Now what about the I net? So for I net I have to calculate what is the current that goes inside the small radius r. So total this current. So this current I want to take. Okay. So for that what I am doing, so let us say I am drawing another loop. Okay. So by moving a distance of small x, let us say, I draw a circle and then I move another distance of dx. So I take an element like this. What is the shape of the element? Cylindrical shell. Why? Because this wire is cylindrical in nature. No, this is not spherical wire. This is a cross section of a cylindrical. So it is a cylindrical wire. Okay, cylindrical wire. So that means this geometry is basically cylindrical shell geometry. Shell geometry. So within that small element, I want to calculate what is the di number. So what is di? Di should be j into area. J into area. So j into area. Area is how much? 2 pi x dx. Can I say that? 2 pi x dx. Okay. Let us say j is j naught into x. Why? Because r is nothing but x. So ultimately we got 2 pi j naught into x square dx. That is a small current that flows through this elemental cell. Okay. So total current is how much? Total current is basically integration of this. So I net should be equal to how much? Integration of di. Limit is from 0 to smaller. Limit is from 0 to smaller. So ultimately what I am getting, 2 pi j naught into x cube by 3 means r cube by 3. So 2 pi j naught r cube by 3, that is the value of I net. So once I put that I net over here, I can get the value of B inside. So finally answer is B inside is how much? So B inside should be equals to mu naught by 2 pi small r into I net. I net is again 2 pi j naught into r cube by 3. So 2 pi cancels out. So ultimately what I am getting, mu naught by 3 j naught into r square. This is the number of B inside. Now in the question you are asked to calculate the magnetic field at point P. So at point P, put the small r values equals to capital R. Okay, put the small r values capital R. So finally our answer at regarding the magnetic field at this point would be how much? B should be equals to mu naught j naught capital R square by 3. That is our answer. Now regarding the direction, place the thumb along the cross direction because I is cross. Okay, curl your finger. So once I curl my finger, now my finger is passing in the vertically downward direction at this point. Understand? This is the direction of B at. Here the B will be this direction, vertically downward direction. Okay. So only thing is that you have to measure the magnitude from the Ampere law. Now using the right hand thumb rule or cross product rule, calculate the B direction at point. এবার ধরলাম যে now the J is constant. Let us say J is constant. It is not a variable. So J, once it is constant, now I can apply the formula mu naught J R by 2. There is no issue. But I have to calculate the magnetic field at point P, which is at a distance of 8r from the center of the larger circle. এইগুলো কি সার্কুলার ওয়্যার? These are not circular wire. These are the cylindrical wire. কিন্তু cross section দেখছি, এটা কিন্তু cross section দেখছি. So cross section is circular. So from the center, so center will be over here. Center will be over here because the 2r is the radius of the larger circle. and 2r is the diameter of the smaller circle, so O is the center, and inside there is a cavity, so this is the cavity. Okay, this is the cavity. So cavity means there is no current is being flow. So instead of assuming cavity, what we can assume that there are two circles. One circle cross inside total current, cross inside, and another circle is plus, another circle is there, is dot inside. So combination of these two circles gives the entire result. So radius of the circle is how much? 2r. Radius of the circle is r. ডটটা আমি অ্যাড করলাম যাতে করে ক্যাভিটা ফিল করতে পারি, কারণ রেজাল্টটা কি আছে, রেজাল্টটা যে মিউ নট জি আর বাই টু রয়েছে, দ্যাট ক্যান বি অ্যাপ্লিকেবল অনলি হোয়েন দ্য সলিড সারফেসে, না, ইফ দ্য ওয়্যার ইজ সলিড দেন অনলি আই ক্যান অ্যাপ্লাই। কিন্তু অঙ্কতে দেখলাম কি ওয়্যার ইজ নট সলিড, সো সাম পার্ট অফ দ্য ওয়্যার ইজ ক্যাভিটি। ঠিক আছে, তাহলে এবার উইথ রেসপেক্ট, দিস ইজ দ্য ও পয়েন্ট, ভালো করে শোন, দিস ইজ দ্য ও পয়েন্ট. Let us say I am drawing another point O1 over here, and this is the center of the O1 circle. O1 is this point. So point P is located at a distance of 8r from point 2. Now 8r from point 2, and similarly 8r minus 2r, that is 8r minus that is 7r from point 1. Can I say that? So 8r distance is the distance of the point P from the O. So from point O1, that is the center of the smaller circle, is the distance 7r. So for the larger circle, if I say this is the J, so this is also J because J is uniform. Both are having the current density J. So for this, the P is outside point. P is outside point. So for P to be outside point, the formula is mu naught I by 2 pi. Solid cylindrical wire is there, and I want to calculate the magnetic field at point P. So formula is mu naught I by 2r. So here the formula will be mu naught I by 2 pi r, that is here. But carefully you have to apply. For the first wire, so if I place my finger cross and if I curl the finger, if I place my thumb cross, okay, and stretch the finger towards point P, the palm will give the direction of the magnetic field at point P, and that magnetic field will be downward. Is that true? There is the B1. Similarly, if I place my thumb dot and stretch the finger, place the finger dot and stretch the finger towards point P, so palm will be upward. So B2 is upward. B2 is upward. So net B at point P should be equal to B1 minus B2. What is B1? B1 is mu naught I. I is what? J into pi into 2r whole square by 2 pi 8r. This is the B1 number. What is B2? B2 should be equal to mu naught I by 2r. Mu naught I. I is what? J into pi into capital R square divided by 2 pi r, 2 pi 7r. Okay, so ultimately r pi will cancel out, so mu naught J 4 r by 16. Nah, mu naught J into 4r by 16, so ultimately mu naught J r by 4, this number. And what about that number? That is pi cancels out, mu naught J capital R by 7. Mu naught J capital R by 7. So B at point P should be equals to B1 minus B2. You know? 14 হবে, 7 হবে না, 14 হবে, 14. Okay, so B1 minus B2, so mu naught JR by 4, mu naught JR 1 by 4 minus 1 by 14, that will be your answer, and direction is downward. This is down. Okay, so this is about the cavity problem. So point is outside. Now the point may be inside also. Let us say I am taking the same situation where the point P is inside. Okay, now point P is inside. So if the point P is inside, Now again draw the two circle. Let us say this is the larger circle. So for the center is O and this is the point P, which is a distance of capillary from O1 point. And there is smaller circle of center O2. So for O2 point, this is the O2 point, distance of point P is 2R. Distance of point P is 2R. But that is outside. For O1 circle, current is cross. For O2 circle, current is dot. Okay, current is dot. So for the larger loop, formula is mu naught J by 2. So if I place the thumb along the cross direction and stretch the finger towards P, then the magnetic field will be downward for the O1 point. So this is the B1. Similarly, keeping the dot magnetic dot direction of current, so towards point P, again it will be downward direction. Cross, so B1 will be upward. So B1 will be upward because cross is the direction of the current. So B1 will be upward and B2 will be downward. Okay. So for B1 I should use the formula mu naught J by 2. So mu naught J capital R by 2. That is the formula. Why capital R? Because R is the distance. So formula is B should be equal to mu naught J small r by 2. What is small r? Small r is the distance of the point from the center. So from the center, P is at a distance of capital R. So mu naught J r by 2 simply. And B2 should be how much? B2 should be mu naught I by 2 pi. So mu naught I is how much? J into pi capital R square by 2 pi R. 2 pi into 2R. So ultimately what I am getting? Mu naught J capital R by 4. Okay. So B2 is negative, B1 is positive. So if I take B1 is positive, B2 is negative. So B at point P should be equal to mu naught J capital R by 2 minus mu naught J capital R by 4. That is your answer. But ultimately your direction is upward. Okay. So the point may lie inside the conductor or may lie outside. So in this situation, one point is inside. So for that you should use the formula mu naught J r by 2. Another point is outside. For that you use the mu naught I by 2 pi R. বোঝা গেছে? হয়েছে? That is the last problem. Now the point is somewhat at an angle with respect to O1 and O2. Okay. This is the O1 point. This is the O2 point. Again the same dimension is there. Let us say the radius of the larger circle is 2R. The radius of the smaller circle is not 2R. R1 R2 ধরে দেখি let us say এইটা নাম্বার দরকার নেই কারণ ওই ডিসটেন্সে জানা আছে so radius is not given, so on the geometry is given, but entire thing is that this part smaller circle represents what? Represents the cavity part. So whatever the current is there, that is there inside this part. This part is filled with current. So again I have to draw two circles. One is the larger circle and the smaller circle. For the larger circle, B is cross. For the larger circle, B is cross. So not B, I. So I is cross. Because I want to calculate the B there. Let us say I is flowing in this direction cross. I, V now. Okay. So current is being flowing in the cross direction. So I is cross direction is given for the circle larger. So cavity has to be replaced by a dot. Okay. So cavity has to be replaced by a dot. So let us say for the point P, let us say this is the larger circle, this is the O1 point, and P is somewhat over here. Let us say this is at a distance of small r1. Let us say P is at a distance of small r1 for the larger circle. And I say that for the larger circle, current is being flowing in the cross direction. Okay. So P is the inside part. So magnetic field at point P should be how much? Should be mu naught J r by 2, that formula. But what about the direction? So stretch the thumb along the I direction because that is the DL vector. DL cross R, I am using a wire saver law to find the direction. So along the thumb should be cross and place your finger towards your R. Place your finger towards your R. Stretch your finger towards your R. So magnetic field at point P should be in a direction B1 like this way because B1 should be perpendicular to this. Okay. Let us say this angle is theta 1. Let us say this angle is theta 1. Okay. So correspondingly, this vertical angle is also theta 1. Now, vertical angle is theta 1. Okay. Now, what about the B1? So, B1 should be equal to mu naught J R1 by 2. Mu naught J R1 by 2. Now, come to the smaller circle. So, for the smaller circle, this is the O2 point. Let us say this is the point P. So, this distance is, let us say, R2. Let us say this distance, radial distance from point O2 is R2, but here the current is flowing in dot direction. Okay, current is flowing in dot direction. So dot means place your thumb along dot direction, stretch your finger angle R2. So now perpendicular to that should be the direction of B2. Okay, again if I say this angle is theta 2, this angle is theta 2. So this B2 is making an angle vertically theta 2. Okay, so B2 is making an angle theta 2 with the vertical. Now come to the point P. At point P, there is one component of B1 is in here. So whose vertical component is theta 1? Vertical angle is theta 1. At point P, another vector B2 is there. Whose vertical component is theta 2? Whose vertical component is theta 2? Got it? Now, so that means if I consider the triangle O1 O2P, triangle O1 O2P, for O1 O2P triangle, this is the O1 O2P, the P point, this O1 point, this is O2 point, and I say these are R1, these are R2, this is theta 1, these are theta 2. Nah. Okay. So, can I say that R1 sine theta 1 should be equal to R2 sine theta 2? From this triangle, can I say R1 sine theta 1 should be equal to R2 sine theta 2 because this should be the vertical height, this height. Nah. So, for this two triangle, R1 sine theta 1 equals to R2 sine theta 2. Now, once I take the component, now B1 sine theta 1 and B2 sine theta 2 will be cancelling out. Why? Because R1 sine theta 1 should be equal to R2 sine theta 2. That means what you can say that mu naught into J R2 sine theta 2 by 2, that should be equal to mu naught into J R1 sine theta 1 by 2. What I am doing, multiplying both sides by mu naught J by 2. If I multiply both sides by mu naught J by 2, that is a constant number. So that means the sine component cancels out. So whatever the magnetic field is there, that is the cos component, that is this direction. Okay. So B net should be equal to how much? B net should be equal to mu naught J by 2, J by 2 into R1 cos theta 1 plus R2 cos theta 2. R1 cos theta 1 plus R2 cos theta 2. Can I say that? So R1 cos theta 2 plus R2 cos theta 2. R1 cos theta 1 plus R2 cos theta 2. Now, R1 cos theta 1 plus R2 cos theta 2 is what? So, this is R1 cos theta 1 and that is R2 cos theta 2. That means total distance between the center of the two circles, and that is given by the L. Okay. So, ultimately what I am getting that B net is equals to mu naught J by 2 multiplied by this number, and that number is nothing but our L number. So our answer for B net is equals to mu naught J L by 2. That means if I place point O1 and O2 at a distance of L, magnetic field inside this is a constant, uniform. Magnetic field inside any point P So point P may be any point, it depends on the distance between O1 and O. That means very important thing is that what is the L vector direction? L vector is along, so this is basically in a vector format, it should be not J L vector by 2. L vector is what? Line joining from O1 to O. So along this L vector, magnetic field will be there. So inside this cavity part, so all the magnetic field vector will be in this direction and they are uniform. Okay. So this is the variation of the magnetic field inside the cavity. Yeah, this is the variation of the magnetic field inside the cavity part, which is uniform. Why uniform? Because I am getting the number is mu naught JL by 2. Okay. Mu naught JL by 2. Mu naught JL by 2, where L is constant number. L is what? Separation between O1 and O2. That gives the answer.